Welcome back to another explainer, everyone. Okay, I want you to just imagine for a second that you're an astronaut. You're out there floating in the endless dark, about to embark on a journey that literally baffles the greatest scientific minds on Earth. Today, we're diving straight into the universe's absolute ultimate mystery, its most terrifying giant, the black hole. We are going to break down exactly what happens inside, step by terrifying step. So buckle up because this ride is going to be incredibly mind-bending. So let's set the scene with a seriously stressful what-if scenario. Imagine you're in an advanced spacecraft, and somehow things go horribly, horribly wrong. Your engines fail, you're just drifting, and then boom, you're being pulled straight toward a black hole. Do you end up in another dimension? Do you time travel? Or is it just a really weird, terrifying end? Well, throughout today's explainer, we're going to look at exactly what the science says actually happens to you. Section 1. What exactly is a black hole? At its core, a black hole is basically the ultimate cosmic collapse. When a star that is way, way larger and heavier than our sun finally runs out of fuel, it collapses violently inward under its own immense weight. The entire mass of that massive star shrinks into an impossibly tiny space. We're talking literally smaller than a mustard seed. And this creates a gravitational grip so incredibly powerful that absolutely nothing can escape it. Not even light. Now, size absolutely matters here, and it drastically changes your fate. On one end of the spectrum, we have stellar mass black holes. These are born from dying stars and weigh about 5 to 30 times the mass of our sun. But on the other end, we have the true monsters, supermassive black holes. These absolute units contain the mass of millions or even billions of suns. In fact, hiding right at the very center of our own Milky Way galaxy is a supermassive black hole named Sagittarius A. Moving right along to Section 2, approaching the monster. As you drift closer, the very first bizarre thing you'd witness is something called gravitational lensing. The black hole's gravity is so absurdly strong, it literally bends the fabric of space around it, kind of like a giant warped magnifying glass. The light from the stars sitting behind the black hole gets bent and stretched into crazy, smeared shapes. You might even see the exact same star appearing in 2 or 3 different places all at once. It's visually stunning for sure, but also deeply terrifying. And man, if this particular black hole is actively feeding, you are in for a seriously rough time. You'd run right into an accretion disk. You see, when gas, cosmic dust, or even shredded stars fall toward the black hole, they don't just drop straight down. They start spinning around it at absolutely blinding speeds, creating this flat disk. And because of the extreme friction, this disk gets unbelievably hot. It becomes one of the brightest things in the universe, blasting out lethal X-rays and high-energy radiation. Honestly, before the gravity even gets you, the intense heat and radiation from this glowing disk could just roast you alive. Which brings us to Section 3. Spaghettification, the deadly stretch. Yeah, it's really called spaghettification. As you get closer, you'll start feeling extreme tidal forces. Because you're falling feet first, the gravity pulling on your feet is significantly stronger than the gravity pulling on your head, simply because your feet are closer to the black hole. So first, you get pulled down hard. Second, this massive difference in gravity physically stretches your body out thin, just like a noodle. And third, all at the same time, space forces squeeze you in from the sides, exactly like squeezing toothpaste out of a tube. You literally become human spaghetti. But here's a wild twist. Your experience depends entirely on which type of black hole you fell into. If you fall into a smaller, stellar mass black hole, those tidal forces ramp up so fast that you'll be violently spaghettified and completely disintegrated before you even reach the edge. But, ironically, if you fall into a giant supermassive black hole, it's actually way safer. Well, at least initially. Because it is so massive, the edge is much further away from the center, so the tidal forces at the boundary are quite weak. You could cross the edge completely intact without even feeling a bump. But hey, don't celebrate yet. The spaghettification still happens. It's just delayed until you get much deeper inside. All right, Section 4, Event Horizon, the point of no return. The event horizon is the absolute point of no return. You can think of it as the ultimate boundary line of the cosmos. Once you cross it, your fate is sealed forever. It's effectively a one-way door into the unknown. Once you slip past this invisible threshold, the gravity is so intensely powerful that the speed you would need to escape it is actually faster than the speed of light. And since nothing in the universe can travel faster than light, nothing can ever come back out.
Think of it like being in a boat heading toward a massive waterfall. Early on, the water is moving pretty slowly. If you turn your engine on full blast, your boat's top speed is faster than the current, so you can easily escape upstream. But as you get closer to the waterfall, that water speeds up. Eventually, you hit a point where the water itself is flowing faster than your boat's absolute maximum top speed. At that exact moment, no matter how hard your engine works, you're going over the edge. The event horizon is exactly that point, but for the actual fabric of space itself.
So, you slip past this terrifying threshold. There's no physical wall, no electric shock or anything. You're just in free fall. But I have a really important question for you. What actually happens to time when you cross that boundary? Well, this is where Einstein's theory of relativity really bends your brain. Time is not absolute. It actually changes based on gravity, which is an effect known as time dilation. If a friend is watching you from a safe distance through a telescope, they will never actually see you fall in. Because the extreme gravity stretches the light waves, your friend will see your movement slow down until you appear completely frozen right at the event horizon. Your image will slowly turn red as the light loses energy, and to them, you'll be stuck there for eternity. But for you, you look at your watch and the second hand is ticking completely normally. You experience a smooth free fall right across the boundary. It's literally two completely different realities for the exact same event. And finally, Section 5, the ultimate end, the singularity. Once you're inside the event horizon, everything you know about navigation completely breaks down. If the black hole is feeding, you might still see some distorted light from the outside universe shining in behind you. But inside, space and time are so warped that direction basically loses its normal meaning. You can try to fire your thrusters to go left, right, or even backwards, but the space-time geometry is curved inwards. Every single possible direction you can move now inevitably leads straight to the center. All paths lead to the singularity. And then you arrive, the singularity. The numbers here are practically impossible to fully wrap your head around. The singularity is the very center, where all of the black hole's immense mass is concentrated into a point with exactly zero volume and infinite density. This is the ultimate dead end. It's where Einstein's general relativity and quantum mechanics just crash into each other and completely stop making sense. Space and time, as we know them, cease to exist. And whatever is left of you, well, it simply ceases to exist too, becoming one with this infinite point. But hey, let's indulge in a really wild thought experiment for a second. Because time slows down so drastically for you due to that extreme gravity, millions of years are ticking by in the outside universe while you just experience mere minutes. If you could somehow miraculously survive at the singularity and look back out into the universe, you wouldn't just see the stars, you would see the entire future of the universe fast-forwarding right before your very eyes. Billions of years of cosmic history playing out in a few seconds. I mean, what a truly spectacular concept. Now, I know exactly what you're thinking. What about the movies? Come on, is there a secret exit? Let's separate sci-fi from reality here. Filmmakers love wormholes, right? Those magical cosmic shortcuts to other galaxies. But scientifically, even if a wormhole somehow formed inside a black hole, the math shows it would be incredibly unstable. You'd crash into the singularity long before getting through. Okay, what about white holes, a place where things only get spat out? That's pure mathematical speculation with absolutely zero evidence. And yes, Stephen Hawking did prove that black holes leak Hawking radiation and eventually evaporate, but that takes trillions of years. It's way, way too slow to save you from your inevitable spaghettified fate. Sci-fi is fun, but man, physics is a cruel mistress. Which brings us to our final thought today. If the singularity destroys space and time as we know it, could it be hiding fundamental truths about our universe that we simply don't have the physics to comprehend yet? Black holes teach us the very limits of our reality. And while a lot of this sounds totally like fiction, it is grounded in real science that we are still actively discovering every single day. With new tools like the James Webb Space Telescope giving us totally unprecedented views of these cosmic giants, who knows what mind-blowing truths we're going to uncover next. So keep looking up, stay curious, and keep asking questions, because the universe is just full of wonders. Thanks for hanging out, and I'll catch you in the next explainer.